is Olivia Daniel, and I will be your teacher today. Our current lesson is electrolysis conversions. So electrolysis is best described when you break it up into two separate words. So the second half of the word, right here, lysis, is a Latin root, so it means to break apart. So the best way to explain this is breaking apart an electrical current. So electrical energy input is used to cause an unfavorable redox reaction to place out a solid mass of neutral metal from aqueous ions, which sounds like a mouthful, but it's easy when we get into it. So electrical cells are different from galvanic cells in the factor that current is applied. So you can use an electrolytic cell to calculate time to plate a given mass to plate in given time, and electrons or the charge transferred throughout the reaction. So the current would be this equation right here, I equals Q over T. I is current in amperes, Q is the charge in coulombs, and T is time in seconds, or 1 ampere is 1 coulomb per second. So what is most used in this practice is Faraday's constant, which is 96,485 coulombs per 1 mole of electrons. So the math to be used for electrolytic conversions starts at a variable of time, and it will carry out all the way until you get a mass. You can start at any time within here, and you can reverse some of the methods used to get to whatever you need to, but this is just the basic structure so you can hit every single topic. So you will start with a certain amount of seconds. Multiply that by the coulombs that you should be given per the 1 second. So this is your current. So past that, you'll multiply 1 mole of electrons divided by Faraday's constant, which, as I said before, is 96,485 coulombs. Multiply that by 1 mole of X, or whatever you're working with, which will be different in every case. This is the mole-to-mole ratio. So 1 mole of X per however many moles of electrons, which you will find out when you're given your equation. Then finally multiply that by your mass in grams of X over your moles of X, as you will with any stoichiometry problem. And that's will give you blank grams of X. That's your final mass. So this is your molar mass here. This here is your mole-to-mole ratio. That's moles of electrons transferred per 1 mole of X, or whatever substance you're using. And then Faraday's constant. So I'm just going to put F. So this is your basic equation that you will use for all of this. And that was electrolysis conversions with Olivia Daniel. Thank you.